In this lesson we will be creating a split shank. We will create this with variables so it can be easily modified and be used as the base for many different models. So we're going to create a new file and a new part with basic closed solitaire template, and we'll name our file. Okay, so we'll be creating everything within this design, keeping in mind that we want to bring in variables and tweak them from our driving parameters. We'll start off by bringing in some ring shank sketches, and then we'll sweep them for the lower end of our shank. Design sketches ring shank sketches. We're going to be using these square ring shanks, and we'll place one at the 6 o'clock datum and one at this side datum. Okay, now we're going to create some variables so that we can control these 4 dimensions. Okay, so I'll insert variables. First variable, I'll call it the side shank width, this 4.4. Let's set it to be 4. Middle click to add a new variable. We're seeing them coming in our expressions here. Side shank thickness now. Let's set it to be 2. Middle click, we're bringing in 2 more variables. Bottom shank width, let's say 2.5, and bottom shank thickness. We'll set this to be 2, the same as the side shank thickness. Now let's link these up. Change our entity filter onto sketch. Double click to enter into the sketch environment of one of our ring shanks. We can show target. Double click on a dimension. Click on the A to select the variables from our variable browser. We'll navigate into the correct part. Okay, that being the split shank square template, we'll find our variable. This one is the bottom shank width. Okay, as we plug it in, you should see it update to that dimension. Bottom shank thickness. Double click to enter into our side shank sketch, and we'll do the same again. Double click, select variable. This is the side shank width, and here's the side shank thickness. Okay, so these variables are all linked up now. We can add them into our driving parameters. Let's first of all clear out the driving parameters. Left clicking and middle clicking, then left click, middle click. Just clear out these default variables. We'll leave the ring size in there. Now let's add in our new variables. We left click on an asterisk, right click, browse variables. Let's start off with side shank width, left click, side shank thickness. Press apply to lock them in there. Then we can test them to see that they're working. Okay, and they seem to be working, so we'll confirm. Now let's make this into a complete shank. First we mirror this side shank across the side datum plane. Now let's come in with the curve for the shank path for use during our drive curve loft. Wireframe, pick the arc, let's give it a color green. The first point we're going to be snapping to datums, so let's change our entity filter to datum to make sure it is snapping to the right place. First point, second point, midpoint, there's our curve. We can hide our template to view things more easily. Now let's perform that drive curve loft. Pick our curve, and then we're going to pick our sketches. Okay, I picked it at the wrong point. You have to pick them at the same point on each sketch. Okay, we don't need to keep the curves, but we'll have the end caps. confirm. Okay, so there is our ring shank. Okay, I'm also going to add in another variable. If I bring back my template and I show the dimensions of the template, I also want to add in a variable to change this angle, to change how far along our split comes around the ring shank. Okay, something's going wrong there. Let's step through the history to see where our issue is coming from. Okay, so we moved that datum. Okay, so it looks like I did not place this side ring shank sketch onto the datum. I placed it onto the curve. So we can right click, relocate the sketch, the plane, picking it on this plane, and we want to use the centroid defined by plane. Confirm. Okay, so we've relocated the sketch there. Let's step through the history to make sure everything else is coming in fine. Okay, so that was my own fault. I did not place the sketch onto the datum. I must have placed it onto a point on the template. Okay, so let's set up a variable for this value. Insert variable. Let's call this the split angle from the 3 o'clock. This is the 3 o'clock and this is the angle from the 3 o'clock. Split angle from 3 o'clock. Okay, and let's set it to be 10. Now we can link this up by double clicking on our dimension, selecting the variable split angle from 3 o'clock. Okay, and it updates to the 10. Let's add it to our driving parameters. Left click, right click, browse variables, split angle from 3 o'clock. There it is. Apply. Let's check it out. Okay, it seems to be working fine. Let's see if it can go below the 3 o'clock without issue. That seems fine as well. Okay, so now we need to create this split for the split part of our ring shank. I want to split this edge in half. Okay, and we do have a split edge command. It is not in our wireframe tab, it is in the heel tab. We have a split edge command that allows us to split our edge. I want to split it in the middle. Confirm. Okay, so now we have split this edge into 2 segments, into 2 edges. Okay, we're going to do the same for the opposite side. Middle click, the edge, the point, use our input options, right click, middle of the same edge, confirm. Okay, so now we have split our edges. I now want to create a curve, a 2-point line, from the end point of one edge to the end point of the opposite edge. So it's a split down the middle. Then we're going to insert a curve list, these edges, and then the 2-point curve. Okay, so now we have a curve list, a rectangle or a square in this case, that we will be sweeping along a new curve to create our splits. Okay, so now we need to create this curve. Now we will be creating this curve out of 2 other curves using a combined projection. Okay, so we need to create 2 curves first of all. I'm going to insert a sketch on the front datum, confirm the operation. First of all, I'm going to reference one of these edges. Then we can hide the 3D environment by showing our target. Let's go into a plane view. Okay, I'm going to turn this into live geometry by right clicking on it, toggling the type. It's currently construction geometry, which means we wouldn't see it in the 3D environment. Okay, now I'm going to draw a construction line. I'll turn on my construction geometry, 2-point line. I'll just draw a line, let it constrain to be horizontal. Let's turn off the construction. I'm going to dimension this, right click, quick dimension. Let's just say 4 millimeters. Okay, this is just going to be a constant to lock it in. Okay, now I also want to add dimensions to this endpoint. So I'm going to dimension it from the origin to the endpoint. Okay, and I want this vertical dimension here. Okay, controlling this. Let's say 12. Okay, and I'll do the same for the horizontal to that point. So we have control in these ways. Let's say 2. Okay, and the purpose of this will become clear. I'm going to finally add in a 2-point line. Let's give it a constant dimension just to lock it in. Let's say 5. And finally we'll control the angular dimension here. Okay, so let's just turn the dimensions into grey that we will not be modifying. Just control picking them, right click, attributes. I like to grey them out. Okay, so we have these 3 dimensions that we need to set up variables for, because we want control over them. Let's set this to be 30. Okay, so what we will be doing is in a 3D environment we will be blending between these 2 curves. Okay, and the reason we do this in a 3D environment is to ensure that we keep tangencies. We want to have a tangent curve coming from here down to here. Okay, so let's do this to make it more clear. Okay, let's blank out the JCD template, and we'll also blank out our ring shank, the lower part of our ring shank, so that we can see our curves clearly. Let's use the blend tool. We'll be blending from the end of this curve down to the end of this curve. Okay, and here you can see how our tangencies are being kept. We could play with the weights, but I'm going to leave them at the default value of 1. Let's confirm the operation. Okay, so this is one of the curves that we'll be using to perform a combined projection. Now we have 3 dimensions in there that we need to set up variables for. Let's go back into the sketch to have a look at them. I'm going to right click on the sketch and edit it instead of redefining it. Okay, so now we can see how if we were to change the angle here, when we regenerate our history in the 3D environment, the tangency will update to keep in line with the tangency of this curve. Like so. Okay, so this is the purpose of our sketch. Now we need to set up 3 variables. One here. This could be our X angle for the split. We have an offset here. This could be our X offset. And then we have a Y offset. Okay, all of which will influence the resultant blend. Okay, so let's set up those variables. Insert variable. Let's call it the split top X angle, and we'll set it to be 20 degrees. Middle click, another variable. We'll call this one the split top X offset. I'm going to copy this just to make things easier for inputting our later variables. Okay, so this offset, let's say 1.5. Middle click. I'll perform Control V to paste that text back in, but I'm going to change this to a Z. Split top Z offset, let's say 10 millimeters. Okay, now we need to link it up into our sketch. I'm going to edit the sketch. Okay, let's double click. This is our Z offset. This one here is our X offset, and finally we have our X angle. We'll add these into our driving parameters. Okay, let's see how they affect our curve. Okay, so this is how we are influencing our curve, or one of our curves. Now let's create the second curve. First of all, I'm going to unblank my ring shank, and I'm going to trim it in half. Trim the shape to the side datum plane. We don't need to cap the trimmed region because we'll be mirroring and sewing the shape later on. So I'll confirm here. Here we don't have our end cap. We don't need it. Okay, now let's create our second curve. Right click, insert sketch on our side datum plane. Okay, once again I'm going to reference this shank, show target. I'm going to change this into live geometry. Okay, now we need to set up in the same way our second curve. Okay, so first of all I'll create a construction line coming from the origin up. Okay, I'm going to give this a dimension straight away, quick dimension, and this is going to be the Z offset. Okay, so the same as within our other curve. Okay, then I'll create another 2-point line. Let's take off the construction geometry. I'll create it out in space. Okay, we'll be using this as our angular control like we had for our previous sketch. So let's set up some dimension constraints. Okay, first of all we'll do the offset here. Okay, we'll give this a constant value to lock it in. I'll change the color to grey so that I know that I don't need to modify it. Okay, so we have this one constraint to control the, the Y offset. Okay, this one we don't need to modify because it is already linked up. Okay, I want to bring in a constraint to constrain these two to be on the same horizontal axis. So this point's horizontal. Okay, I'm going to come in with another 2-point line construction between here. Okay, and this will be to use as our angular reference. Quick dimension, we're going to dimension this angle. We have control here. Okay, so we will be performing our blend between these 2 points using the lines as the tangencies. So we have 2 more variables we need to create. This will be our Y angle and our Y offset. Exit back out. Okay, let's insert our variables. We had the split top Y offset, let's say 4, middle click, and our split top, this is the Y angle. Let's say 110 degrees. Check that they're all coming in well. Right click, let's edit our sketch again. link these up, we had the Y angle and the Y offset. Okay, now let's perform our blend again. Wireframe, blend between these 2 points. There's our second curve. Let's add our attributes into our driving parameters. Let's just check that they're working nicely. Okay, so we'll have a look at our Y angle. Let's increase this. Okay, so that's working as it should. And our Y offset. Okay, so now we need to perform a combined projection to combine these 2 curves to create one curve. Okay, so we use this combined projection command. Our first curve, pick the direction. Our second curve, pick the direction. Okay, and there's our combined projection. Okay, now we can visualize this if that was a bit confusing. Instead of doing the combined projection, we can extrude our curves. Okay, and the combined projection is where they intersect. Okay, so that is our intersection curves. Let me just erase these shapes now. Okay, so that is the same result as if we were to do the combined projection. Okay, so that's more of a visual way to help us understand the combined projection. Okay, but this does it in one go. Okay, so now we have our curve. Let's sweep along it. Shape, sweep. The profile is the curve list that we created before. And then the path is our combined projection curve. Confirm the operation. Okay, so here is our split. Let's erase all of the leftover curves, or sketches, they're probably sketches. Middle click. Okay, now let's mirror our split shape. First across the front. Middle click, we'll mirror all 3 shapes now across the side. Now we can perform a Boolean add at the same time. Okay, to form one complete shape. So here is our split shank. Let's save. Okay, we can take a look at our parameters now, how it's all working out. Okay, so we have our split from the 3 o'clock. Change this to bring our split further down. Okay, we have our shank thicknesses and widths. Okay, so we have the side shank width. We can increase this. The thickness. Okay, we have the bottom shank width. And the thickness also. Okay, now bear in mind that the side shank width, okay, this will control the width of our split shank here. Okay, so the split part of the shank will be half of our side shank width. Okay, so these will be each 2.5 millimeters in width. Okay, next up we have our X angle. Okay, so the X angle, if we remember, will control this angle here. Okay, so we can use this to create interesting split shanks. Let's bring back our JCD template. Okay, we have our Z offset. We can increase the size of our split shank. We'll bring it down to the ring finger. Okay, the X offset is how far away from the center our split shank goes. Okay, we have the Y controls here, the Y angle and the Y offset. Okay, so looking from the side view, you have the Y offset. The Y angle. Okay, so this is our split shank template created with the controls so that we can use it for multiple designs. We can use it as the starting point for multiple designs. Okay, and of course we have control over the ring finger size. Now we have a problem here. It looks like I didn't set this shank to be on the datum plane either. Okay, so I need to modify that. Yep, another mistake. Right click, relocate this plane. Replay. Okay, so that's good now. Okay, so this is our split shank square template.